Hi, everyone, and welcome to What's New for Data Protection on Amazon S3. My name is Nitish Pandey. I'm a product manager on Amazon S3 team.
And my name is John Robe. I'm a software engineer for S3, and I'll be stepping off for the beginning portion of this session.
Thanks, John. Today, we are going to talk about some new capabilities that we have added recently for data protection in S3. Before diving deep into these features, I would like to share a fun fact. How many objects do you think we store in Amazon S3? Raise your hand if you think it's around 10 trillion objects. 100 trillion objects? 200 trillion objects? I heard a billion. So great, we store more than 200 trillion objects in Amazon S3. That's almost 26,000 objects for each person on this planet, and roughly 100 objects for every known galaxy in the universe. And I would like to thank you for trusting us with those objects. The protection of every single one of these 200 trillion objects is our top priority. And in addition to all the work that we do behind the scenes to keep your data secure, we also give you a ton of capabilities that you can use to implement a security posture that is tailored to the requirements of your applications. Before I share the features that we launched today, let's quickly talk through the data protection features that we have launched in 2021. These features help you access your data securely and make it easier for you to manage and control access for your shared data sets. Then we'll cover two new features that we have launched today. They are a new object ownership setting in S3 and a really cool policy validation feature for checking S3 policies. This will be followed by a brand new upcoming feature for performing faster data integrity checks when you upload and download from S3. And finally, the most exciting part, demo. We will do a demo on S3 object ownership setting, policy validation, and the new checksum capabilities in Amazon S3. So let's start with our first feature, and that is Amazon S3 support for private link. AWS Private Link for S3 makes it simple for your on-prem application to directly connect to Amazon S3. This is an overly simplified view of what our customers do when running an application on AWS. They run applications on EC2 and use VPC, and they route requests to S3 through a gateway-style endpoint. This is the most simplified view of what many of our customers do today to access Amazon S3. What customers have asked us for is a means to have the same simple architecture for their on-prem apps. Customers told us that they want to allow their on-prem apps to easily connect to S3 over a private connection, and they do not want to use S3's public IPs. In the past, to fulfill this requirement, they had to operate a fleet of proxy servers with private IP addresses in their VPC. So that's what we delivered with AWS Private Link support for Amazon S3. Now, you're able to directly connect your on-prem applications to S3 without adding the operational complexity of running proxy servers or using S3's public IP addresses. Great. So now your apps on AWS and on-prem apps both can directly access data in S3. But what if you want to manage and control the access pattern for each one of them? So the next feature that we want to cover helps you manage the access to your shared data sets at scale. Back to our previous chart, except we are going to add this additional layer in here, which is S3 access points. S3 access points give you the ability to stand up multiple custom endpoints on your bucket. So in this case, you have 3 apps in your environment, and you can use access point to have a dedicated endpoint for each of these apps. And that allows you to write dedicated policies, segment traffic, or do a lot of stuff on access control side, which makes it easier to manage. The problem with these is that you connect to S3 using an access point through an Amazon resource name and not with the traditional bucket name. So in July, we introduced S3 access point aliases. S3 access point aliases allow any application that requires an S3 bucket name to easily use an access point. So you may ask, how do I create access point aliases? Aliases for S3 access points are automatically generated when you create an access point for a bucket. And they're interchangeable with S3 bucket names. And for existing S3 policies, aliases have been automatically assigned and are ready for use. You can use an access point alias anywhere a bucket name is used today to perform object-level operations such as a put or get request. So to summarize, every access point in S3 now gets a unique alias. You can use them anywhere you use S3 bucket names, which means that the application that expect a bucket name are now compatible with access points without having to make any changes to code. This includes AWS services such as Amazon EMR, Storage Gateway, and Athena, as well as open source packages like Apache Spark and Amazon Partner Network applications. Now let's talk about a new capability that we launched recently, multi-region access points. Customers told us that they want an easy way to store, replicate, and access copies of Amazon S3 data stored in multiple AWS regions. So in September this year, we introduced multi-region access points, or MRAP. With multi-region access points, you can accelerate and simplify storage for multi-region applications. It provides you a single global endpoint to access a replicated dataset stored across multiple buckets in S3. And when you make a request to this global endpoint, that's when the magic happens. It automatically routes the request over the AWS network to the S3 bucket with the lowest network latency, which can accelerate the operation performance by up to 60%. This allows you to take advantage of the AWS global infrastructure and thus avoiding congested networks on public internet and improving application performance anywhere in the world, all while maintaining a simple region-agnostic architecture. My favorite part of this feature is this new user experience that you get for managing all aspects of multi-region S3 setup. In S3 console, multi-region access points present a centralized view which shows replication regions, buckets associated with an access point, replication metrics, and request routing configurations for your multi-region S3 deployment. For example, you can see here in a single view all the buckets that are sitting behind this access point, which we call reInvent MRAP. Then this map shows you the replication relationship between those various buckets. And we also have a segment here that allows you to set up replication rules across as many buckets as you want, thus making it very easy to set up and drive multi-region storage. Overall, this gives you a much simpler and centralized way to build, manage, and monitor storage for multi-region applications. Now, I'm excited to talk about a new feature that we launched today. This new capability is an extension of S3 object ownership bucket settings. So without further delay, let's see what this new feature will do for you. In S3, there are multiple ways to provide access to your data. You can use IAM and IAM policies to define who can access what, which means what resources the IAM users and roles can access in your account. Then there is bucket policy, which is a resource-based policy. You can grant or deny permission to different users through the bucket policy. This is usually how you provide access to your bucket to an external AWS account. And finally, there is access control list, which is the original method to control access to your S3 buckets and object. It is an atomic attribute that is attached to every object and each bucket. Note that ACLs are a legacy access mechanism that predates IAM policies and S3 bucket policies. We at S3 recommend our customers to use policies instead of ACLs for a long time. And this feature allows you to disable ACLs and so that you can easily enforce this best practice. To understand this feature better, let's first look at how cross-account write works today. As more and more customers are using Amazon S3 for building data lakes, they use cross-account write as a fundamental step. In this example, you have account A, and you have a bucket that serves as a core part of your data lake. Then you have account B, which is an external account. It can be your application sitting in an external AWS account, or a third-party application like Databricks or Terraform writing objects to your bucket. Now for the write to succeed, account B needs to give you the permission to read the object through access control list. Second, once these write operations are successful, these objects are accessible to you. However, you don't own them. They're still owned by account B. And then the third problem is, if you want to give access to objects written and owned by account B to other accounts such as C, D, and E in this case, using bucket policies, you won't be able to do that because you're not the owner of the objects written by account B. And in order to share those objects with other accounts, you will have to use access control lists. As I mentioned earlier, we recommend using a bucket policy instead of ACLs to share your data. You should use bucket policies to share data with other AWS accounts and to create a security parameter to deny access. Thus, we always recommend our customers to use bucket policies whenever and wherever applicable. However, access control list limitation creates a pain point for our customers. So let's take a look how access control list affects what's applied to a bucket policy. In the first use case, if you have IAM roles or users within AWS account writing objects to your bucket, you'll own these objects. You will also own the objects written by different IAM roles within your account. Now let's assume that we have an external account writing objects to your bucket. And you have a bucket policy that allows, in this case, account yellow, to read and write from the bucket. And you want to enable sharing to another account using this bucket policy. You will notice that you are not the owner of the objects written by this external account, as we discussed. Objects written by this external account are owned by this external account. And now you as the bucket owner cannot further share these objects written by this external account via bucket policy because you don't own these objects. So to address this use case, we have added a new capability to S3 object ownership, a bucket enforce setting that you can apply. And this new setting will help you in two ways. First, it will make sure that ACLs are disabled. And second, it will ensure that you, as the bucket owner, own every object in your bucket. It means that bucket policies will be the sole means of sharing data, and you don't have to worry about ACLs. Going back to our previous slide, where we shared different access control methods, This new setting simplifies access control management and disable ACLs, thus allowing bucket policies and IAM policies to define all access controls. Going back to our previous example, let's assume that you have applied this new setting, the new object ownership setting. You'll notice that the objects written by other accounts are automatically owned by you. So this helps you standardize the ownership of your objects in your bucket by making sure that bucket policies are applied to all objects in the bucket without any exception induced by ACLs. Now, when you use this setting, you don't have to worry about these three problems that we discussed. First, you don't need to specify ACLs for cross-account write. All the objects are going to be owned by you. It means by the bucket owner. And finally, you don't need ACLs to give access to other accounts. So you can reliably use bucket policies for all the objects in your bucket. It is a bucket level setting, and we are adding this as the third option to S3 object ownership. It's called bucket owner enforced. You can apply it to your existing bucket or to a new bucket. And if you want to turn it off, you can do it anytime. And when you do that, the previous ACLs will be restored. The other feature that we launched today is dynamic policy validation of your S3 policies. Policy validation with Access Analyzer guides you to author and validate secure and functional policies with more than 100 policy checks. You can use these checks while creating new policies or to validate existing policies. You can use the policy validation to confidently check that your policies provide intended access before they are attached to IAM principals or S3 buckets. To save you time and improve your security posture, this saves you time and improves your security posture while simplifying permission management at scale. Policy validation feature contains over 100 encoded checks based on AWS policy writing best practices. It analyzes the policy to dynamically generate findings that help developers identify issues while authoring. Findings are then categorized into 3 buckets: errors, warnings, and suggestions based on their impact. Error findings are generated when a policy statement is non-functional. For example, the policy validation generates an error when developers wrongly specify use list buckets instead of list all my buckets. Warnings are generated when a statement contains construct that may make the policy prone to security risks. For example, the policy validation generates a warning when a policy construct allows an IAM principal to pass any role to any service, which may result in an escalation of privileges. Finally, suggestions. Suggestions are generated to recommend stylistic improvements that don't impact the access allowed by the policy. For example, the policy validation generates a suggestion to remove redundant actions and help author well-structured policy within the policy size limits that are easy to understand and maintain. You can use the filters provided by policy validation to focus on resolving a specific category of findings. Policy validation is turned on by default in the JSON policy editor, in the IAM console, and S3 console. In IAM console, you can view findings generated by the policy validation when creating a managed or inline policy for your IAM principals. In S3 console, you can view findings generated by the policy validation in the S3 policy editor when creating a bucket or an access point policy. The policy validation dynamically generates and updates its finding as you edit your policy. These findings guide you by providing actionable steps to fix the issue in a policy statement, along with the links to AWS documentation. You can click on a specific finding to identify the location of the associated statement within the policy. The findings get resolved once the policy is fixed. We have some more exciting news to share. We are adding new checksum capabilities in S3 to verify integrity of your objects when you upload and download from S3. This is a brand new feature, and I'm not going to steal John's thunder, so John will share more details around it.
Thanks, Satish. So today, I'm incredibly excited to announce that new checksum options will be coming soon to S3, which will accelerate integrity checking of requests by up to 92%. For the first time in the cloud, you will be able to choose from 4 supported checksum algorithms for data integrity checking of your upload and download requests. In addition, enhancements to the AWS SDK and S3 API will significantly improve checksum efficiency. So, if you don't know what a checksum is, a simple way of thinking about it is that it's the digital fingerprint for an object which can be used to track any change in data during transmission or at rest. And how do we use checksums? It's simple. You calculate the checksum of the object at the source, then after the transmission, and you compare the checksums. If they match, then perfect. Your data, despite traveling at the speed of light, is still unchanged. If they don't match, it means the source object and the destination object are not the same. And S3 can use this information to only succeed the request when these checksums match. Now that you know about checksums, let's talk about the new integrity checking capabilities in Amazon S3. But first, let's cover the customer use cases that prompted us to build these features. To start, we have a number of customers who are migrating their entire on-prem data infrastructure or digital assets stored on other clouds to AWS. They are moving billions of objects and hundreds of petabytes of data to S3 and Glacier. In many cases, these customers receive or collect data from multiple sources using different checksum algorithms. Customers told us that they trust AWS, but they also want to verify every byte landing on AWS as a best practice, and to confirm that the data was transferred without any alteration. To cover these use cases, we are excited to share that for the first time in the cloud, you can choose from 4 supported checksum algorithms for data integrity checking on your upload and download requests. The algorithms are secure hash algorithms and cyclic redundancy checks. Now you can choose a SHA-256, a SHA-1, a CRC32, or a CRC32 checksum algorithm, depending on the compliance or performance requirements of your application. In addition, you can select one of the 4 algorithms and provide a pre-calculated checksum value already stored on your system. Amazon S3 will use that checksum value to validate the objects, and it will store that value throughout the lifespan of the object in S3. We will preserve the checksum value you provided during lifecycle transitions, replications, moving to another storage class, or any other S3 operation. Even after 100 years, and not all of us are going to live another 100 years, when you download the object, we will use the exact same checksum you provided at the time of upload to offer you end-to-end data integrity, and we will validate it on that download as well. We also talk to customers who are dealing with bigger and bigger objects. From media houses who are generating ultra-high definition videos using the best cameras available, to geospatial companies translating Earth as a data set by capturing and storing high-resolution images of the planet, to research institutes storing and processing large genome data sets. These are a few examples, but really it's something that we're seeing across industries. As data sets grow, object sizes generally do as well. for a bunch of workloads that are running on S3. And as that has happened, integrity checking gets harder because, well, math. Checksums take longer and longer to run, and that means it becomes more expensive and time-consuming. So we went back and we tried to figure out how we could make integrity checking on big objects faster and more reliable for customers. At the end of the day, if you want to speed something up by an order of magnitude or so, you're going to need to figure out a way to parallelize it. And that's what we've done here. We're introducing two optimizations for integrity checking that together can accelerate your integrity checks by up to 92%. The first thing that we did was enable you to pass in a checksum as a trailer instead of only as a header, which is what we do today. Now, this seems a bit subtle, but it has a huge impact. It means that we can calculate a checksum as you stream the bits into S3, and then just tack it on to the end of the request. The second thing that we did was to enable customers to break objects, large objects, into parts, and then checksum those parts in parallel. We enable this both on upload and later on when you come back and download that object. This is a big deal too, because it means that we don't have to sequentially process a huge object, which can be terabytes in size. Now you can break it up and farm that work out to many cores, all working in parallel to verify your object. So that's what we've done, and we can't wait to get it into your hands. Let's dive a bit deeper on these options so you can see how each of them works. So first, let me talk about trailing checksums. Today, to verify the integrity of your data, you can either provide a pre-calculated value with your request or have the SDK calculate a value before it streams the data into S3. But these two things, the calculation of the checksum and the streaming of the bits into S3, have to happen sequentially. This means that both operations take wall clock time as well as their own processing power, which means more time and cost. But with trailing checksums, what you're doing is you're able to calculate a checksum as you stream the data into S3. This saves you time as you're both able to verify and transmit your data in a single pass, instead of as two sequential operations. To do that, you specify the checksum algorithm in the checksum algorithm member of the put request using the AWS SDK, and you upload the object. The AWS SDK will automatically calculate the checksum and append it as a trailer to that request. This workflow is efficient and will save you time and resources, as you don't have to calculate the checksum on the client side separately before uploading the object. It also enables computing checksums on streaming uploads, where storing the object to a disk or in the memory as an intermediate step wouldn't be possible. And since it's not a reInvent presentation unless it has XML or REST in it, here's what it looks like in the actual S3 API. We're using the AWS chunked content encoding scheme to enable us to send additional contents after your object data in the HTTP request, in what's called the request trailer. You can see that we specify an XAMZ trailer header telling us that you're going to send us an XAMZ checksum SHA-256 value in that trailer. And then you include that data after you send us the object. Previously, all additional data that you sent to S3 had to be in the header of the request, or before the object data. Now, let me talk about parallel checksum operations. Now when you upload a big object into S3, you're using the S3's multi-part upload API to do that. And you may not be aware of that, since oftentimes the SDK or transfer manager is abstracting that away from you and breaking up your big objects into smaller parts under the hood. This allows the SDK to parallelize using more compute and network bandwidth. Our new checksum options will continue to work for multi-part uploads with minimal changes, just like you do with simple single-part objects, you can now pass in a new checksum algorithm like SHA-256, and will happily check that single part with the algorithm that you specify. Now, just like we do with our MD5 checksums today, the whole object checksum will actually be a checksum of checksums. So how do we calculate that value? It's computed by checksumming each of the individual parts' checksums to provide a whole object checksum. And this is useful, but to compute that value later on, I need the part sizes or boundaries to do a full object validation for any object sitting in S3. And that data isn't easily accessible today. Now, let me take a step back and talk about why we needed to do this. So we set up a lab to quantify the impact of parallelization. And what we found was that to do a sequential checksum on a 1 terabyte object on a modern EC2 instance, it took about 86 minutes. Now, you could probably speed that up by using bigger and better instances as they come out, but that's only going to have incremental improvements. So, to help you completely parallelize checksum operations, we are launching a new API called getObjectAttributes, which will provide part-level metadata and checksums. When you call this API against an object in S3 and you specify the object parts attribute, it will give you the checksum algorithm, the checksum value, the number of parts, the part boundaries on your object, and the part-level checksum values. This gives you all of the information that you need to go run integrity checks on a big object in parallel down to the part level. So whereas a single checksum on a large object took 86 minutes before, with those same EC2 instances, we were able to get the integrity checking time down to just 7 minutes. We think this is a game changer for customers who need to run big integrity checks, and we're super excited to make it available to you. So to summarize, the new checksum capabilities coming soon will accelerate integrity checking of requests by up to 92%. You'll be able to choose from 4 supported checksum algorithms. It'll support data integrity checking on uploads and downloads, and enhancements to the SDK and APIs will significantly improve checksum efficiency. And now, we'll be moving on to the fun portion of the session, the live demo. In this demo, we'll cover the 3 new features launched today and coming soon. We'll start by demonstrating the object ownership enhancements. Then we'll use the new IAM policy validator tool to write some new bucket policies. And finally, we'll upload some objects with the new checksum options coming soon. So today I'll be using the AWS console for this demonstration, but you can do this with the SDK as well. So I have here a bucket, reInvent Demo 2021, and in this bucket, I have several objects. And some of these objects were uploaded using ACLs, or access control lists. And some of these objects I want to share, specifically these 2 photos of my dog Sky. And other objects in this bucket I don't want to share with anyone, specifically the secrets.txt file. And so I'll take a look at this secrets.txt file and look at its permissions. And we can see here that it was uploaded with a read permission on its ACL for everyone. And I'll admit that it was for the purposes of this demo. So if we take a look at this object in our web browser with no authentication, you can see that it is indeed publicly accessible. And so that's a problem. And there are a few ways that we could go about fixing this. We could open up this file, we could go to permissions, and we could edit those permissions individually and uncheck these boxes, and then save it. But I have other objects in this bucket that are using ACLs, and I really want to use the AWS best practice of using IAM policies. So instead, I'm going to take a look at the permissions on this bucket, and I'll stop right here for a second and quickly say if I really care about public access, I could turn on this block public access feature that was launched a couple years ago. But today I want to demonstrate the new feature, so I'll scroll down and look at the new object ownership setting. I'll click on Edit, and I've got this new ACLs disabled option. And you'll see that all the ACLs in my bucket will be disabled, and I see that the bucket owner enforced setting is being set. So I'll go ahead and save those changes. Great. So with those changes saved, I'll look at my objects, and I'll open up this file again. And I might get a cache hit on this first one. There we go. So if I refresh, I can see that the access denied is correctly being set on this object, which means that the ACL is disabled. Great. And next, I'll try to look at my images that I was previously sharing using ACLs. And that's the SkyPup2 photo. So I'll copy the URL of this object and view it without authentication. And we see again that because I was sharing it with an ACL, that I can't access it, which is correct. It's what I'd expect. So what I'm going to do next is I'm going to write a bucket policy to make this object public again using the new policy editor that was launched today. So if I look at the permissions on my bucket and I click on Edit on the bucket policy, I can see the new policy editor, and I can notice a few things off the bat. It's giving me a few suggestions here. It's telling me that I've got an empty object principal, empty array actions, and an empty array resource, which is expected. So the first thing I'll do is I'll also notice that I've got an editor right here on the right, and it's going to be able to guide me through writing a new policy. So I'll enter in my service, and I'll type in the action that I want to write or give access to, and I want to give access to the get object action. So I'll check that. And then I want to limit it to only things under the SkyPup prefix. So I'm going to choose object. I'll type in my bucket name. And then object name. I'll allow anything under the SkyPup prefix, and I'm going to go ahead and add that resource. Okay. Now I notice I also still have a suggestion here, and I want to make this publicly accessible. Again, this isn't really a best practice, but I'm just doing it for this demo. So I'll give access to all principals here and make it public. And then I'm going to give it a name, dog photo sharing. Great, so that's a policy constructed using the policy editor. I've got one more policy that I want to add here, and I've pre-created it for you for the purposes of this demonstration just to save a little time. And it's to give my friend Alice access to write objects to her folder. So I'm going to go ahead and copy that in, and we can see right away that it's flagging that I've got a syntax error around line 15. And that's correct because I forgot to copy in that comma. Great. So that's fixed. Now I'm going to mess around with this policy and see what types of validation errors that it's going to come up with. So first I'll edit that account name, and I can see that an error is coming up, and it's telling me that I've typed in an invalid ARN account, that 123456565 is not valid. Provide a 12-digit account ID. Great. So that's one thing that it's already told me. Now, let's add another action here. I want to allow Alice to also delete objects in her folder. So I can see that as I'm typing, it's telling me when I'm making JSON syntax errors and where to fix them. So I'm going to go ahead and start fixing it. And I'll start typing in the new permission that I want to give. Okay. But now it's telling me that the action S3 delete objects doesn't exist. And that's expected because the actual permission is S3 delete object. Okay, great. So that's a quick example of a couple things that the new inline policy validation tool can tell you. And there are a lot more that I haven't demonstrated here, but to keep this demo short, I'll just keep it at that. The last thing that I wanted to show, however, was this preview external access capability down here at the bottom. And if I choose this and I click on preview, it will look at my current bucket policy and tell me a summary of all of the permissions that I'm giving with this policy. And it's telling me that all principals have read access, and that's correct because I've done that here with this statement. And it's also giving me a nice red tag telling me that I'm making objects public, and that's great. It's also telling me that I've given an AWS account write access, and I've given specifically the delete object, input object permissions. So that's great. That's also what I'd expect here. So because this is a fake account, I'll just delete that statement real quick. And I'm going to go ahead and save these changes. Okay, so with those changes saved, if I go back to the photo of my dog and I refresh it, we can see that I've now given correct access. Okay, so great. The last thing that I want to demonstrate today is the new checksum capabilities that are coming soon. And so I'm going to upload 2 new objects to my bucket, specifically 2 new photos of my dog Sky. And I'm going to do that using the new checksum capabilities, and I'm going to verify that my objects were uploaded using checksums. Okay, so to do that, I'm going to click on Upload. I'm going to drag in a photo, and I'm going to scroll down to Properties for that object, and I can see that I've got a new option here, Additional Checksums. And me, being the durability-obsessed engineer that I am, I have a catalog of checksums that I keep for my dog photos. And so I'm going to copy in a checksum that S3 will use to verify to make sure that the object data isn't changed during that upload. Okay, so I'm going to copy in actually the wrong value here first to see what happens if I give a checksum that won't match. And when I click on Upload, you can see that very quickly it's telling me the pre-calculated value that I provided for this object doesn't match the data that it was calculated on the S3 server. Great. So now I'll copy in the correct checksum, paste that in here, and I'll upload the object. So now, as it's uploading the object, it's storing that checksum along with the object data, and it's also validating the object and checksumming that on our server, and it will only store that data if those checksums match. Great. So that uploaded successfully. The next object I'm going to upload, but this time I'm not going to specify a pre-calculated value. Instead, I'll let the AWS console upload that checksum or calculate that checksum while it's uploading it. So I'll go to Properties again, and I'll turn on Additional Checksums, and I'll select a SHA-256 checksum here, and I'll leave this pre-calculated value blank, and I'll upload the object. Okay, so now the console's computing the checksum as it's uploading the data, and that checksum will be stored with the object during its entire lifespan in S3. So if I take a look at this object in the console, and I scroll down, I can see that there's a new box here called Additional Checksums, and I can see that this checksum value was the one that was calculated during the upload. And if I compare that against my catalog, I can see that that's indeed the checksum value that I expected. And so if I go back and I look at that object in the console, I can see that my object was uploaded successfully. And so that concludes the demo today. And so to quickly recap, we turned on the new object ownership setting to disable ACLs on my bucket. We used the new policy editor and inline policy validations tool to write 2 new statements and 1 new bucket policy. And finally, we uploaded 2 objects using the additional checksum capabilities that are coming soon. And with that, I think Nitish has some final words to say. Back to you.
Thanks, John. Hope you enjoyed the demo and really excited about the new features that we have launched. So to summarize, today we talked about 6 features. So the first feature that we talked about is S3 support, Amazon S3 support for Private Link, which allows your on-prem apps to directly connect to S3. Then we talked about S3 access point aliases that your application can use wherever bucket name is required. We also talked about multi-region access points, which gives a simple and centralized way to build, manage, and monitor storage for multi-region applications. Then we talked about a new feature, a new object ownership setting, allowing you to disable ACLs and enforce bucket policies. The other new feature that we talked about was policy validation in S3 Policy Editor, which dynamically checks your policy as you author them. And finally, we announced a brand new checksumming feature, a set of new data integrity capabilities in Amazon S3 that you can use when uploading and downloading objects from S3. One more part I would like to add here is that these checksum capabilities are applicable to all the object types in S3, whether it's a multi-part upload, single upload, or encrypted objects. So that's all we had today. It was great meeting you all in person, and thanks again for joining us. John and I will be here. If you have any question, please feel free to ask us. And please provide your feedback on the session survey. We use these data points to improve the re:Invent experience for you. Thanks again.